Hello students, welcome to this video tutorial on calculating theoretical probability, method 2, using fractions. Okay, so we'll discuss in a moment why method 2 will be helpful. So let's get right into it. Example 1. What is the probability of flipping tails twice in a row? So obviously we're talking about flipping a coin, right? So up to now, what we did was we listed all of the possible outcomes. So what I want you to do is just over here in the corner, I want you to list all of the possible outcomes. Now remember, we're flipping a coin 2 times in a row. So if we were to do it in a systematic way, we could have heads on the first flip, and heads on the second flip. We can then have heads on the first flip and tails on the second flip. We can have tails on the first flip and heads on the second flip, and then we can have tails on the first flip and then tails on the second flip. So what is this question asking? Well, this question is asking the probability of flipping tails twice in a row. So that is this outcome right here. So if we look at this possible list of outcomes, this would occur 1 out of 4 times. Now, to use this method, which we've used up to this point, it wouldn't take very long because we have only 4 possible outcomes. But let me show you how it's going to work using method 2 with fractions, okay? So we divide the question up into 2 separate parts. So in our first flip of the coin, let's calculate the probability of getting tails. Well, when we flip a coin, there's only 2 possible outcomes, heads or tails. So we have a denominator of 2 possible outcomes. And how many times would tails appear? Okay, 1 time out of 2. Okay, the probability of tails is 1 over 2. Now, let's talk about flipping the coin a second time. I'm going to completely ignore the first flip. So what's the probability of flipping tails? Well, again, it's going to be 1 over 2. Okay, 1 out of 2 chance to get a tails. So what we do is, to calculate the probability of tails, that equals, we take the probability of tails on the first flip and we multiply. So this is very important. So what this method does is, we're multiplying fractions together, okay? Times the probability of tails on the first flip. So let's bring these fractions down. The probability of getting tails on the first flip was 1/2. And then the probability of getting tails on the second flip is 1/2. So remember how to multiply fractions? We multiply the numerators. 1 times 1 is 1. And then we multiply the denominators. 2 times 2 is 4. Okay? And then we have to ask ourselves, is this in its lowest form? Yes, it is, because the numerator is 1. Okay, so that's the first example. So you might be thinking, well, this method 2 is actually a longer method than method 1 of writing out all of the outcomes. Okay, so that brings us to example 2. What is the probability of rolling double 5s? Okay, so either you do it with 1 number cube or 2 number cubes, it doesn't matter. So if you were to do it in a systematic way to list all of the outcomes, we would start with the first roll, and we could get a 1 and a 1. And then we could get a 1 and a 2. And then a 1 and a 3. And then a 1 and a 4. And then a 1 and a 5. And then a 1 and a 6. And then we could start with the 2's. So you can see that we'd actually have to list quite a bit of outcomes here. Okay, quite a few outcomes to find the probability of rolling 2 5s. Well, let's use method 2, using fractions. What is the probability of rolling a 5 with the first roll? Well, we know in the number cube there are 6 numbers. And 5 is only 1, it only appears 1 time. So the probability of rolling a 5 is 1 out of 6. Now, let's roll the number cube again. So again, we're going to ignore the first roll, and let's roll it again. So what is the probability of rolling a 5? Well, again, we have a total number of outcomes of 6, and 5 is only one of those outcomes. So we have 1 over 6 and 1 over 6. So let's jump down to the next line here. The probability of rolling a 5 and another 5 equals the probability of 5 on the first roll, which is 1/6, times the probability of 5 on the second roll, which is 1/6. Okay, 1/6 times 1/6. We multiply straight across the numerators. 1 times 1 is 1. And then we multiply straight across the denominators. 6 times 6 is 36. Then, before you leave the question, ask yourself, is this fraction in its lowest terms? Well, because the numerator is 1, yes it is. Okay, so you might be thinking, well, is this fraction here always going to be the same as the second fraction? And of course the answer is no. So let's look at example 3. What is the probability of rolling double 3s if you have one hexahedron die and one tetrahedron die? So a little more vocabulary for you here. So in order to understand what these are, you need to look at the prefixes, hexa and tetra. Okay? So what does hexa mean? Think about your shapes, starting from a triangle, quadrilateral. What does hexa mean? Well, hexa means 6. So this is a 6-sided die, which is a normal die, which we call a number cube. And then let's look at this prefix. What does tetra mean? Well, tetra means 4. Did you ever play that video game from long ago called Tetris? Well, the reason why it's called Tetris is all of the shapes in the game of Tetris are comprised of 4 cubes or 4 squares. Okay, so we have a normal number cube of 6 sides, and then we have kind of a weird number cube of 4 sides. So this is very important that you know the difference. Okay, so what we're going for is double 3s. So let's look at the first roll, okay, of the first hexahedron die. So what is the probability of rolling a 3? Well, it has 6 sides, and the number 3 appears only one time on those sides. Okay? Now let's look at roll 2. Roll 2, we're going to use the tetrahedron die. Tetrahedron has only the numbers 1, 2, 3, and 4. So the total number of outcomes is 4. And then how many times would a 3 appear? Well, it would appear one time. Okay? So you see now we have an example where these fractions are not the same. All right, so what is the probability of rolling a 3 on the hexahedron die and a 3 on the tetrahedron die? Well, we take the probability of 3 on the first roll, which is this number right here, 1/6, and we multiply it by the probability of getting a 3 on the second roll, which is this right here, 1/4. Okay? So could you multiply those two fractions out? I'll give you a 5-second head start. All right, so hopefully you got an answer here of 1/24. Then ask yourself, is this in its lowest form? Yes, it is, because the numerator is 1. Okay. So let's go on to the last example where we're going to have 3 independent events, 3 things that have nothing to do with each other. So the question is, what is the probability of spinning a green on a 4-section spinner, where the 4 sections are green and then red, red, and red? So if you don't know what that looks like, always draw yourself a picture. So it's a 4-section spinner with 3 sections that are red and 1 section that is green. Then we're going to flip, we want to see if we can flip a heads on a coin and then rolling an even number on a number cube. Now when I say number cube, it always means the hexahedron die, the 6-sided number cube. All right, so let's see, how about I give you a head start here and let's see if you can fill this in. All right, so if we spin the spinner, what is the probability of getting green? Well, remember, it's a 4-section spinner. So the denominator is 4. And how many of those sections is green? Well, if I look at my little diagram here, I can see that only one section is green. Okay? All right, now let's talk about the coin. This is easy, right? Whenever there's a coin involved, it's always going to be very simple. So what is the probability of getting a heads? Well, it's going to be 1/2. Now let's go to the third event, rolling an even number on a number cube. So remember, a number cube has the numbers 1 to 6. So how many of these are even? Okay, oops, sorry, not the 1, 2, 4, 6. Okay, so we have 3 favorable events over 6 possible events. But hopefully you recognize right away that 3 over 6 can be reduced to 1/2. Now, you don't have to reduce the fraction here, but it's just going to let us avoid reducing later on. So it's probably a good idea to reduce right here when you can. Okay? All right. So what is the probability of getting green, heads, and an even number? Okay, so let's start with the first thing. What's the probability of getting green? Well, it is 1/4. What's the probability of getting heads? 1/2. And then what's the probability of getting even? That is 1/2. Okay? So, when we multiply these out, let's go step by step. 1 times 1 times 1 equals 1. 4 times 2, which is 8. 8 times 2, which is 16. Is this in its lowest form? Yes, it is, because the numerator is 1. So hopefully, with using the whole point about using this technique is it's supposed to be faster. And that way you can avoid listing all of the possible outcomes. All right, I hope this helps. Thanks for watching. Bye.